Mental representation. A representation is a label or symbol that stands for something in its absence. Internal or mental representations are the product of perceptual processes and the means by which we store information in memory. There is a debate about whether mental representations are analogical, sharing features with the thing they represent, propositional, in the form of abstract, meaning-based symbols for objects in the world, or distributed as patterns of activation across neural networks. Symbols are the representations that are amodal. They bear no necessary resemblance to the concept or percept they represent. The systematic correspondence between the two domains may be a matter of convention only. For example, in algebra, we denote the different variables as x, y, z, and so on, but neither of these symbols have a direct resemblance to what they represent. Similarly, while solving a geometrical problem involving geometrical shapes, we might assign symbols such as a, b, or c to such geometrical shapes, even though these symbols do not have a direct resemblance to the shapes. Images are another way how the information can be represented in our minds. Images are basically representations that resemble what they represent in some non-arbitrary way. The systematic correspondence between the two domains is iconic. For example, a map of a particular city, or a caricature might resemble to what it is supposed to represent in terms of features iconically, but is not an exact replication of the same. Symbols and images are some basic ways by which information can be represented mentally. Some things such as visual percepts are almost obviously represented as images, while some other things such as abstract concepts are a difficult thing to represent as images. For example, if a person is feeling tired of listening about a particular movie, so then it would be difficult for that person to represent that feeling as an image. Furthermore, some things fall in between the two. For example, the concept of a dog in general. This concept of dogness can both be represented as a visual percept as well as an abstract thing. Imagery and functional equivalence hypothesis. Mental imagery, varieties of which are sometimes referred to as visualizing, seeing in the mind's eye, hearing in the head, imagining the feel of, etc., is an experience that resembles perceptual experience, but occurs in the absence of the appropriate external stimuli. It is also generally understood to bear intentionality, i.e., mental images are always images of something or other, and thereby to function as a form of mental representation. Traditionally, visual mental imagery was thought to be caused by the presence of picture-like representations, mental images, in the mind, soul, or brain, but this is no longer universally accepted. The functional equivalence hypothesis of imagery assumes that visual imagery, while not identical to perception, is mentally represented and functions the same as perception. This hypothesis was first suggested by Shepard and Koslin. According to this, an image is isomorphic to the referent object, second order, meaning spatial relations are analogous, and an image is an analog representation of the object, as shown by mental rotation and image scanning. Propositions. The proposition is the most basic unit of meaning in a representation. It is the smallest statement that can be judged either true or false. For example, Fred is tall, is a single proposition coded as a relation with two arguments, is, Fred, tall. Similarly, the ants ate the sweet jelly that was on the table, expresses four propositions. Furthermore, propositions are a means of specifying relationships between different concepts. Latent semantic analysis is a mathematical procedure for extracting and representing the meanings of propositions expressed by a text. It represents the co-occurrence of words and their contexts. Using a database of co-occurrence relations, it can compute the similarity in meaning of two words or texts. Propositions differ from the images in the sense that they are abstract means of mental representation, whereas the images are the perceptual means of mental representation. Propositions are schematic and verbal, while the images are concrete and nonverbal. Furthermore, propositions can be coded as a relation and arguments, and each proposition is an assertion which may be true or false. Semantic network models versus feature comparison models. A semantic network, or frame network, is a network which represents semantic relations between concepts. This is often used as a form of knowledge representation. Collins and Quillian suggested that a network consists of a number of nodes, which correspond roughly to words or concepts. Each of these nodes is connected to related nodes by means of pointers or links that go on from one node to another. This collection of nodes associated with all the words or concepts one knows about is called the semantic network. The feature comparison model assumes that the meaning of any word or concept consists of a set of elements called features. These features are of two types: defining features and characteristic features. Defining features are those that must be present in every example of the concept, while the characteristic features are those which are usually but necessarily present. This model usually works in stages. In the first stage, the feature lists of the concerned concepts are accessed and comparisons are performed. If the lists show a great deal of overlap, or if the overlap is very small, then the response is made quickly. However, if the overlap is neither very high nor very low, then the second stage of processing occurs where the comparison is made between the sets of defining features only. The feature comparison model also has explained the category size effect, which refers to the fact that if one term is a subcategory of another term, then people will generally be faster to verify the sentence with the smaller category. For example, people would be faster in verifying the sentence, "A Labrador is a dog," than to verify, "A Labrador is an animal." This happens because as categories grow larger, for example from Labrador to dog to animal to living things, they also become more abstract. And thus when the abstractness increases, the defining features become fewer in number. The two models, semantic network model and the feature comparison model, differ from each other on a number of points. Firstly, the semantic networks model is a hierarchical network of concepts, whereas in the feature comparison model, each concept has been defined at each level. Concepts. Concepts are categories of things, events, or qualities that are linked by some common feature S in spite of their differences. Maydeen, in 1989, defined a concept as an idea that includes all that is characteristically associated with it. In other words, a concept can be said to be a mental representation of some object, event, or pattern that has stored in it much of the knowledge typically thought relevant to that object, event, or pattern. For example, for most of the people, the concept of a dog would consist of information that includes that a dog is an animal, has 4 legs and a tail, has a reputation of being man's best friend, is a common pet, and so on. Concepts help us to organize our knowledge base. They also allow us to categorize things, and help us create mental slots in which we can sort the things we encounter and help us to treat the new things which we have never encountered before in the same way as we treat the familiar things that we perceive to be in the same set. Thus, concepts play an important role in our mental life, and without them our lives would be chaotic. Concepts can be of different types. Concepts have been classified into 2 types, namely, simple and complex concepts. Simple concepts are those concepts that are based on a single common feature between various things, events, or qualities. For example, all animals are alive, anything living is composed of cells, etc. Complex concepts are the concepts that are based on many common features between things, events, or qualities. Complex concepts are further divided into 2 types, conjunctive and disjunctive concepts. Conjunctive concepts are those concepts that help us to determine the similarity between 2 dissimilar objects. For example, how is a pencil and a telephone alike? Disjunctive concepts help us to determine how 2 highly similar things differ from each other. For example, how is the right hand different from the left hand?